So today we're going to look at bearing, direction, and resultant force. We've done bearings before when we did law of cosines, but we're going to look at them again, so it's just kind of a quick overview since they're not brand new to you. So here's what we know. We know that the direction of a vector can also be given as a bearing. And bearings are frequently given in application problems. Because if you're actually piloting a ship or flying a plane, you're going to be talking in terms of bearings, not in terms of theta. But theta is what we use mathematically to do our calculations. So here are the two different kinds we're going to talk about. We've got quadrant bearing. That's the acute angle, always acute, between a vector and a north-south line. And so this vector right here is south 60 degrees east. That means we go south and we swing 60 degrees east. So that's 60 degrees right there. So you either go north or south and then you go east or west. Again, review. So then true bearing. That angle is measured clockwise, always clockwise, from the north. So from true north, if it just says bearing and we don't have a south or east or whatever, we start at true north. So for this same vector, this is what we would measure in degrees, and that makes this 120 degrees. So it would just say a bearing of 120 degrees. One thing about true bearing that we didn't talk about before is that they're always written with 3 digits. So if you have a true bearing of 15 degrees, it's written as 015. Okay. Now, that's all fine and great for bearing, but if I'm going to use an angle in the calculator to do some trig on or whatever, I got to have theta. Or if I get an angle from the calculator, it's giving me theta. And so I have to be able to go back and forth from bearings to theta and theta to bearings. So for this same vector, if I was talking theta, we know theta starts here at 0, go all the way around to here. How you determine theta depends on what you're given. There are some rules, some little, you could subtract this and add this or whatever that's kind of generalized, but it doesn't work every time or for every kind of bearing, and it depends on which direction you're going. And I feel like that can be way more confusing than you just thinking around the circle, because you should be able to think around the circle at this point. And so you just decide if you're supposed to add or subtract and what that is, depending on what you know. So if I start here and go to here, I know that that's 270 degrees. If I'm then going to go additional 60, I can just do 270 plus 60, and my theta is 330. Okay? So it's not a you always add or you always subtract. It just depends on what you know and what you need, that sort of thing. Okay? We good? So it's good to have a little picture and label it for sure. So let's look at just some pure quadrant stuff before we move on and apply it. So we're going to give the quadrant bearing and true bearing for each, but we're also going to talk about theta on each one of these, even though it doesn't tell us to, because we've got to connect it all to theta anyway. So for number 1, if this is 85 degrees, this is 85 degrees, that is theta, because I'm starting here at 0 like we know how to do. My quadrant bearing that I need, this to get here, I would go north and swing east. How much I'm going to swing east? Well, if this is 85, I can just do 90 minus 85. That gives me 5 degrees. That makes this north 5 degrees east. My true bearing starts from true north and goes clockwise. Well, that has the exact same, just that same 5 degrees. But since it's true bearing, I have to use 3 digits, so it's 005 degrees. Everybody okay with that? All righty. Number 2. What they gave me is theta, because I start here at 0, so this is theta again. My quadrant bearing for this one, instead of going north, I'd have to go south and swing west. So it's going to be south, something west. Couple of different ways I can figure out what that something is. If I know that this is 212, with theta, if I kept going to here, that's 270. So the difference between 212 and 270 is what this pink angle is, so I can just take 270 minus 212, and that gives me 58 degrees. Another way I could figure it out is I know that going to here is 180, so 212 minus 180 gives me 32, and then I can subtract 32 from 90 to get 58. It doesn't matter. It's whatever makes the most sense to you. Just label the stuff and you should be able to figure pieces out, okay? But this is what I'm actually interested in because this would be south 58 degrees west. My true bearing starts at north and is going to rotate around to here. So if I start here, once I get here, that's 180, and then I have to go 58 more, so 180 plus 58 would give me 238 degrees. Any questions about any of that? All right. So for number 3, they did not give me theta. Theta starts here, it's 0, and goes to here. They gave me this part, which is 24. So if I want theta, I'm going to have to take that 24 and add that 90 to it, and that would give me 114. Okay. My quadrant bearing, I would go north and swing out west, and that's that 24 that they gave me. So this is north 24 degrees west. Then my true bearing, if I start here, go all the way around to here, I've gone almost 360, but I have 24 more to go. So if I do 360 minus 24, that gives me 336, and that's my true bearing. Any questions about the bearings? Do you see how they're different and how you just got to do your pieces together? I don't know how you would do that without a picture. I personally can't do it unless I draw it and actually think about my pieces, or I'm going to lose track of what's where. All right, so let's apply one of these. It says an airplane is flying at a bearing of 245. So it doesn't say anything about north, south, east, west. That means it's a true bearing at 550 miles per hour. Okay, so that's my velocity. So I have the angle and I have the magnitude. It says give the velocity of the airplane as a vector in component form. And remember, component form is always your pointy bracket form. The first thing I'm going to need to do on all of these is I've got to have theta to be able to do any of this. So I'm going to draw my little north, south, east, west here. Think about what's going on with my vector. So 245 degrees. I would start here because it's bearing. We go around, that's 180, 245 lands me somewhere over here. Close enough. Just kind of estimating. You're ballparking it, but you want to be kind of as accurate as you can without actually measuring anything, because that'll be helpful to you. So this is 245 degrees. I need theta. Theta would start here and go around to here. Now again, there are some rules that you could do about subtracting this and adding this in general, but don't bother with that. Last period I had somebody, I swear they spent the whole period trying to figure out what that was, and in the end they were like, oh, well see, you could just do this and add this and that works in general. And I was like, not for this one, because you end up here. And he was like, oh. So that's why I'm telling you, just trust me on this and then just go with what you know. So here's what I know. I know I need this angle. And they don't start at the same place. That's one reason why I can't just add and subtract stuff. But this 245 that I do know, I know if I go to here, that's 180, right? And then I have this leftover stuff. So this leftover stuff right here is the difference between 245 and 180. So if I subtract 180 from 245, this part right here is 65 degrees. Does that make sense? Not my answer, but I know then that if I'm here for my theta, when I go all the way to here, that's 270, but I need to back up 65 degrees. So 270 minus this 65 is going to give me that theta is 205. Any questions about theta? We okay on that? Just piecing what you know together. Think about how much each quadrant is. And it doesn't matter which direction you're going. We're not talking positive and negative here. It's all positive. All right, so I have theta, and I have my magnitude. So I want my component form, so I'm using my trig. I take the magnitude, which is 550. I would multiply that by cosine of theta, which is 205. And then 550 times the sine of 205. Then we would go to the calculator, but don't bother because I'm just going to give you the numbers. If you can't type this in at this point and get the correct numbers, I don't even know how to help you. So I know you can do this just fine. We're going to type that in, and you will get negative 498.469 and negative 232.440. And that is your velocity in a component form vector, which means that vector is the same as this purple one. And what that vector means is that I would go left about 500 and down about 230, and I feel like that makes sense for my little vector that's not exactly to scale, but gives me an idea. Any questions at this point? Okay. Let's look at number 5. So this says, a man pushes a lawnmower with a force of 25 pounds uphill at an angle of 40 degrees. Notice it says nothing about bearing, and there's not a north, south, east, west. We're just going uphill at an angle of 40 degrees. And I want to give the force exerted on the lawnmower as a vector in component form. Okay, so let's think about what's happening with our lawnmower. So this guy's pushing the lawnmower, and we've got an angle of 40 degrees, and the force is 25 pounds. And this is my angle of 40 degrees. So that 40 degrees is my theta. That makes sense? So when you're talking about what your angle is, you're going with the horizontal. So theta is 40. I don't have to do anything to change it from bearing or whatever. So then this one should be fairly simple. The vector is the force, which is 25, times the cosine of 40, and then 25 times the sine of 40. This work is exactly what we did the other day. We're just using it for applications now. Again, you should totally be able to type that in, so I'm just going to give it to you. It is 19.151 and 16.070. And so again, if I think about what that means, I would have to go to the right about 20, up about 16. Looks good for that vector. Feeling good about that. Questions? All right. So then I have a cruise ship. It's sailing at 20 knots in the direction of north, 12 degrees west. I want the velocity of the cruise ship as a linear combination of the unit vectors I and j. Before I get to the linear combination part, I'm going to need it in component form. Even though it doesn't ask me for that, I got to get there first. So let's look at this. We're going 20. Sorry, my Amber Alerts. Okay. 20 knots in a direction of north 12 degrees west. So it looks something like this. This is the 12 degrees, and this is 20 knots. I need theta. They didn't give me theta this time. Theta starts here, and that's 12. So I'm just going to take that 12 plus 90. Theta is 102. Then once you've got theta, the rest is a piece of cake, right? We've got that our vector, that's my magnitude, which is 20 times the cosine of 102, and then 20 times the sine of 102. You type that into the calculator and would get negative 4.158 and 19.563. So once again, I'm going to think about what that means for my vector. That would mean I'd go to the left about 4, up about 20. Looks good. This is a second quadrant angle. I'm not done though, because I need it in a linear combination. Super easy to make it into a linear combination. The vector would just be negative 4.158 times I hat plus 19.563 j hat. Okay. What questions do you have? Okay, so now we're going to look at using more than one vector at a time. You need a calculator handy, and I want you to remember this. On the AP test, you have to be accurate to the nearest thousandth. It doesn't matter how good your work is and how smart you are. If your answer is not accurate to the nearest thousandth, you're not going to get credit for that answer. And what you have to be careful of is that you never, ever, ever type decimals back into the calculator, like rounded decimals. I would never type this negative 4.1 back into anything. You either store it, so if you're using an 84 or an Inspire type calculator, they have the storing capabilities, and you can store it and use it that way. If you need assistance with that, I can help you with that at another time. But I feel like the majority of you are using the Desmos and Delta Math calculators, so that's what I'm going to use, and I'm going to show you how to handle it when it doesn't store stuff for you. Okay, so I'm using the Desmos scientific calculator. I like it a little better than Delta Math, but I don't really remember why. So just have them handy and push buttons along with me when we get there. Okay, so our resultant force. So this says if 2 or more forces are acting on an object, then the resultant force is the sum of the 2 vector forces. So we're going to have 2 vectors at a time here. Number 7 says 2 tugboats are pushing a barge. If tugboat A is traveling in the direction of south 80 degrees east, tugboat B north 65 degrees east. Both boats are pushing with a force of 400 pounds. Find the magnitude and direction as a quadrant bearing of the resultant force on the barge. So let's look at our vectors first. For tugboat A, so we'll have vector A and vector B since we have tugboat A and tugboat B. Tugboat A is going south 80 degrees east. So something like this. This is 80 degrees, and this is tugboat A. Tugboat B is going north 65 degrees east, so somewhere over here like this, and this is 65 degrees. And this is tugboat B. They both have the same force. That's not always true for both of your vectors, but in this case, it is. So before I can do anything, I have to come up with the thetas for both of these. So I'm going to need my theta for vector A, and I'm going to need my theta for vector B. So for vector A, I would start here at 0, go all the way around to here. So in this particular case, the way I would look at this is that I would go all the way to here. That's 270, and then I go another 80. That gives me 350 degrees. You could also think, well, if I'm here at 80, I only have 10 more to go, so 360 minus 10 gets me 350, but it's the same thing either way. For vector B, theta would be this right here. So I would just take 90 minus 65, and that would give me 25 degrees. And those are the numbers that I have to use when I actually do my trig. So I'm going to set up my 2 vectors. Vector A, our magnitude is 400 times the cosine of theta, and theta for that is 350. And then I'd have 400 times the sine of 350. For vector B, I still have 400, but my angle's different, so it'll be 400 cosine of 25, 400 sine of 25. Okay. Everybody understand where all that came from? Okay, so I want the resultant force of both of those vectors, which means I need a resultant vector, which means I need to add those two together. So we're first going to add them geometrically, which means literally with the pictures. So here, I was just kind of estimating where things go. I'm still going to just use my estimations. I'm going to copy this first vector. So I'm going to try and get the same angle for the most part, whatever. So there's vector A. If I'm literally going to add vector B to it, then I go from the tip of this is when I start the next one. So I'll try and copy this. They have the same force, so they should be the same length. So I'm going to kind of do my best to make these two look like they're the same length. It's good enough. We're not trying to make everything perfect. So my resultant vector looks like this. So even from my super rough estimations, I feel like this vector is going to have a quadrant 1 angle to it, right? Does that make sense? Literally just did them kind of like you were doing in Delta Math. But I also need to algebraically do that. So I need vector A plus vector B, which means we add the two x components and we add the two y components. So here's where we're going to go to the calculator, and I want you doing this along with me. So I'm going to do 400 times the cosine of 350, close my parentheses, plus 400 times the cosine of 25. So those are my two x components that I just added together. Then I'm going to go ahead and do my y components. 400 times the sine of 350 plus 400 times the sine of 25. Okay, add the x and the x, the y and the y. Then I'm going to leave it just like that. Don't hit clear or anything. I need that looking at me just like it is. So we're going to go back and we're going to write this down. We've got 756.446 and 99.588. Okay, so before I do anything else, I'm going to think about what that means. That means this purple vector, which is my resultant vector, that I would go to the right about 750, up about 100. I mean, that looks, relatively like that would make sense. Okay, so I feel okay about that. Now that I have that resultant vector, I need the magnitude. I need the magnitude of the vector, my resultant vector, which is those two added together. Remember that when you find the, sorry, I don't even know why my sound is on. When you find the resultant vector, that's the square root of a squared plus b squared. The fact that this is a and b and this is a and b, total coincidence means nothing, okay? This is the a, it's the x component, this b is the y component. I cannot type those decimals back in. If you are typing decimals back in, you are doing something wrong. So if I could store the answers, that'd be great. I can't store them, so I'm going to have to do this a little different. Even though this says a squared plus b squared, would it be the same if I did b squared plus a squared? Because that's what I'm going to do. It's the same thing, right? Okay, so when I look at what I have on my calculator, this gives me the a value, this gives me the b value. I can use this answer button and get the b value, but there's no way for me to get this a value. And just typing these decimals in, not good enough, because it actually stores more than what you see. And there's always somebody that's going to say, well, I typed them back in and I got the same answer. Well, good for you. It's not going to happen every time, and you're not going to know when it happens and when it doesn't. And if you want to take that risk, knock yourself out, but I wouldn't suggest it. So we're going to take the square root. And I want b squared. So I want this answer squared. Like whatever it's telling me the answer is squared, not typing anything else back in. Plus, I don't have an answer button for this. So I'm going to highlight everything I typed in. Then you do Control-C for copy. I'm going to come back here. I'm going to open my parentheses. And then right here, I'm going to do Control-V and paste it in there. Close my parentheses and square it. So now I have b squared plus a squared inside of there. And it's all exact. I didn't put any rounded values in there anywhere. And the answer I get is the magnitude. That's my magnitude answer. So that is 762.974 pounds. Now I need theta. Theta equals the tangent inverse of b over a. Still not typing decimals back in. But now when I go back, I can't grab b or a. I know I could back out of some stuff, but it's not worth my time and the clicks it takes. So you have to keep track of what this is. This gives me my a value. This gives me my b value. So I'm going to take the tangent inverse. Because I'm using the Desmos calculator, there is a fraction button. If you don't have the fraction button, you can use division, but make sure your whole numerator is in parentheses, because I know it'll make a fraction out of it, but it might not make it out of everything you want. And it's b over a. B is the sign one. So I'm going to highlight all of this, Control C, and I'm going to put that in the numerator, Control V. Don't act like you don't know how to copy and paste stuff, because I know you do. And then I'm going to highlight A, Control C, put that in the denominator, Control V, and there's my angle. Now, the first time I did this question, I got this answer, and I was like, oh, I think I did something wrong. And even the first time I did it today, even though I've done this question before, and I even looked back, I was like, oh, no. It made me think I did something wrong because it's not a crazy decimal, but we didn't do anything wrong. But if you type decimals back in, you probably don't get exactly 7.5. I didn't bother to check, but my guess is it's not. So what the calculator gives me here is 7.5 degrees. Not necessarily my answer. That means that this vector here, the angle is 7.5. Totally not to scale there, but that's what that means. It tells me I want my answer as a quadrant bearing. That means I'm going to have to go north, something, east. So I actually need that number. How do I find that number? Subtracting. So I take 90 minus 7.5. That gives me 82.5 there. So this is north, 82.5 degrees east. What questions do you have? We good? Okay. Let's look at number 8. We have two forces with magnitude of 85 pounds and 120 pounds are acting on objects at angles of 35 and 140 respectively. So this 85 goes with the 35 degrees. The 120 goes with the 140. And it says, not only respectively, but with the positive x-axis. That's great news, because that means it starts here with 0. Basically, that's theta. They gave me theta. Then it says find the magnitude and direction to the positive x-axis, which again means theta, right? So I don't have to worry about bearing or whatever. The angles that they gave me are the angles that I get to use. So I'm going to have, for this first vector, my magnitude is 85 times the cosine of 35, and then 85 times the sine of 35. Then for the second vector, I will have that 120 times the cosine of 140, and then 120 times the sine of 140. So I'm going to add them together. Add my x components, add my y components. So on my calculator, I'm going to clear all that mess off. My x components are going to be 85 times the cosine of 35 plus 120 times the cosine of 140. That's my x components. My y components would be 85 sine of 35 plus 120 times the sine of 140. there's my x component and my y component. Okay. So I'm going to write those down. That gives me negative 22.297 and then 125.889. Now, since I didn't have to draw my vectors, I don't have anything to match that up with, but I do need to pay attention to the fact that this is negative positive, so in the end, the angle that I want is a second quadrant angle. Okay? So we're going to find magnitude. Magnitude of vector 1 plus vector 2. Remember, that's the square root of a squared plus b squared. So then I'm going to let the calculator do all that with my exact answers. So this is going to be square root of the last answer I have squared plus, I'm going to highlight the other one and do Control C. Right here, I'm going to open parentheses, Control V to paste it, close my parentheses, and squared. So there's my b squared plus a squared, and I get 127.848. So this is 127.848 pounds. Then I need theta. That's the tangent inverse of b over a. And I go back to the calculator. So I do tangent inverse. I'd like to use my fraction. Makes everything a little easier. It's b over a. B is the sine one, so I'm going to highlight that, Control C, put that in the numerator, Control V. Then here's a, highlight that, Control C, put it in the denominator, Control V. There's my angle. Okay? So I get negative 79.956. Not my final answer. That puts me in the fourth quadrant down here. I don't want to be in the fourth quadrant. I want to be in the second quadrant. So I want to be over here. What do I add? 180. So back in my calculator, I'm going to take that answer and add 180. And I get 100.044. So theta is 100.044. Now, in this particular case, it's asking me for theta because it says to the nearest to the positive x-axis. If I needed a bearing, if that's what I was going to have to figure out, I still have to get this angle because this is my actual angle. So I have to find this actual angle and then use that to figure my bearing out. Does that make sense? All right, so we weren't going to do number 9 anyway. All we were going to do is do the angles. So I'm going to give you what thetas should be. That way you can go and you can actually draw these out, and with it to the left of the statue and all that good kind of stuff, and then you can make sure you can actually find the thetas. So the theta for A would be 125, and the theta for B would be 40. And whether or not you want to do that, that's up to you, but that way you can maybe feel a little bit more confident about how to figure that stuff out. Okay, there you go.